Hello again. I think this is part 13. I'm going to give you two separate scenarios, and you've got to answer a question regarding those two scenarios. It has to do with a truck puts on its brakes, skids. There's no anti-lock brakes, just skids. And it's going to skid on a road. The tires are skidding on a road. And both scenarios, the road's the same, the tires are the same, so that's not an issue. Now, before you think about the concepts, the underpinnings that are required for you to understand relative to answering the question concerning these two scenarios, let's review some points of fact. Okay. The coefficient of friction is going to be determined by the interface between the road and the tires. So that's not going to be an issue. That's the same. Coefficient of friction in scenario 1 is going to be the same as the coefficient of friction in scenario 2. All right. We know that the net force equals MA, and that the friction, the force of friction, is going to equal MA. Why? Because there's no FP once I take my foot off the gas pedal. My foot's now on the brake. So FP is gone. So that truck will decelerate because of an unbalanced force. That unbalanced force is the force of friction. The net force equals the force of friction. The force of friction equals MA. Okay? So that's the equation there. Now, we also know that if I increase the load of the truck, I'm increasing the normal force of the truck because it's horizontal. All right? Now, we have these two equations. F equals MA. I just wrote it a little differently. AM, same thing. And we also have FF equals mu K FN. All right, now, this is the scenario. Scenario 1. I have a heavy truck, and it's going at a certain speed, and it's going to hit the brakes. It's going to skid to a stop. Okay. Now, I double the load on the truck. I double the mass of the truck. Everything else is the same. Same velocity. I hit the brakes. I skid. Question is this. Will the distance the truck travels to come to a stop the same? Is it twice the distance when you put twice the load on the truck, twice the mass? Is it half the distance? What's the relationship between the distance, the distance before and after you double the mass of the truck? What's the answer? Let's examine the facts that I reviewed with you. Okay. Well, notice how I wrote this. I wrote that A as a constant. I double the mass, I double the friction. I double the mass, I double the friction. I double the mass, I double the weight. I double the weight, I double the FN. I double the FN, that's the same, I double the friction. So, you see that mass and friction are both doubling. I double the mass, I double the friction. The friction is the same before and after. It's based on the same thing. It's based on the coefficient of friction. So I have a greater mass, but I have a greater friction. The stopping distance will be the same. It's a little intuitive. If the coefficient of friction is the same in both scenarios, the starting velocity is the same in both scenarios. However, scenario 2 has twice the mass, it has twice the weight, it has twice the normal force, it's going to have twice the friction. You know it's going to have twice the friction in two ways. One, I double the normal force, I double the friction. That's the same. I double the mass, I double the friction. The acceleration has to be the same. Wait, hold it. The deceleration is the same. I'm going to stop. The same amount of time in both scenarios. Same deceleration. I'm going to stop in the exact same amount of time. I'm going to stop in the same distance. Equal distance. Have a great day. Have a great weekend, and I'll see you on Monday. Take care.